In this video lesson, we will learn about two-sided inequalities. Earlier, we only worked with one-sided inequalities. So, for example, a one-sided inequality could be 2x minus 1 less than 5, or 3x plus 2 greater than or equal to negative 3. The difference between one-sided and two-sided inequalities is that for an inequality to be two-sided, there have to be two inequality signs. So for example, negative 3 less than or equal to 4x minus 3 less than 5 is a two-sided inequality. 4x minus 3 has to be both greater than or equal to negative 3 and less than 5. So basically, what this is two different inequalities combined together into one. One of them is negative 3 less than or equal to 4x minus 3, and the other is 4x minus 3 less than 5. And they both have to be true at the same time. So to solve the overall two-sided inequality, we can just solve each of these smaller ones individually, starting with negative 3 less than or equal to 4x minus 3. We do this the same way as we would solve linear inequalities in general. We add 3 on both sides. We end up with 0 less than or equal to 4x. Now we can divide by 4 on both sides. And we get 0 is less than or equal to x. On the other side, we will also need 4x minus 3 less than 5 to be true. So now we should solve this inequality as well. We add 3 on both sides because we want to isolate the variable x. So we get 4x less than 8. Now we divide by 4 on both sides to find that x is strictly less than 2. So the solution to the two-sided inequality is 0 less than or equal to x and x less than 2 at the same time. This can be written down as just 0 less than or equal to x less than 2. Now that we have our answer, let's draw it on the number line and write it in interval notation. So here's our number line. We're going to draw 0 on the number line, and 2, because 2 is the other endpoint. We have x between 0 and 2, so we highlight this, and then we have to mark the endpoints. The 0 is less than or equal to, so we want to include it. The 2 is strictly greater than, so we don't want to include it. That is why we have a solid circle on the 0 and an open circle on the 2. In interval notation, we put a square bracket by the 0 and a regular parenthesis by the 2. So this problem is now solved. We will now move on to a different example, which we will solve with a second method. If before we took our two-sided inequality and split it into two different inequalities that we knew how to solve, method number 2 just keeps the two-sided inequality as a two-sided inequality the whole time. I'll show you what I mean. We want to isolate the variable, so we have to subtract 4. But this time, we subtract 4 on all 3 sides. So we get negative 2 to the very left, which is less than negative 2x, which is less than 2. Now, to simplify this further, we have to divide by negative 2, or multiply by negative 1/2, which is the same thing. Now notice, you don't want to keep the inequality sign the same. You want to flip the inequality. This is the one exception when working with linear inequalities. Negative a half, which we're multiplying by, is negative. So where we had a less than sign, we put a greater than sign. And if there were any greater than signs, we'd switch them to less than. So this flips our inequality, and after we simplify, we will get that 1 is greater than x is greater than negative 1. Notice, we kept the two-sided inequality two-sided the whole time. We never split it into two separate inequalities. So now that we have our answer, it's a good idea to draw it on the number line and write it in interval notation. So here's the number line with the 0 marked, and the endpoints 1 and negative 1. X is between these, so of course we highlight it. And since x is strictly in between it, that is, it's not equal to 1 and it's not equal to negative 1, we put open circles. We do not want to include these points. Written in interval notation, we will just use regular parentheses, negative 1, 1. Thank you for watching this video lecture.